So to find f here, we have to resolve the weight in a perpendicular direction and in parallel direction. We care about the perpendicular direction. It is 28 cosine the angle here. The angle here is, if we looked for the vertical here, we have 90 degree and here is 40, so this is 50. This is perpendicular to the rod, so this is 40 cosine 40, and we can apply the principle of moment because we have equilibrium, frictionless hinge, so we have only two forces, F and this force, and both act in different direction with respect to moment. We have F times distance to hinge, let us name it L, equals the other force times the distance to the hinge. It will be half the length of the rod, so L over 2. Can remove L from both sides, so we have this value over 2, which gives 11. Torque is magnitude of one of the forces times the distance between them. If you want to find the moment of one force to the pivot and the other force to the pivot and add them, it will give you the same answer. Pressure is force over area. Force here is the weight. We can estimate the area if we estimated how much is the length of the foot and how much is the width. Length may be 30 centimeter, width may be 10 or 15 centimeter. Multiplying both of them meter square, 450 centimeter square, or 450 times 10 to minus 4. Oh, gain meter square. We can then divide the force, which is 600, by this number, and answer would be C. Rho is density of water, and V is volume below surface of water because it is partially submerged, not totally submerged. Change in GBE is mg delta H. M is 0.1 kilogram, G is 10, and the delta H is 10, so answer is 10 joule. On platform before jump, it is all gravitational. On way down before cord extend, it is gravitational and kinetic. On way down, as it decelerates, it is gravitational, kinetic, and elastic. And at bottom, when it is stationary, no kinetic, only gravitational and elastic. we certainly need for the force. Okay, distance traveled per unit time is velocity, which is given. Total energy input to sailboat by the wind that depends on uh, force times the distance, and we need force to calculate energy input, weight of sailboat. Sailboat moves horizontally, so the force applied here is horizontal and no need for the weight. Elastic potential energy can be given by half kx squared or half f x, and you can manipulate the formula, but we have here f uh, and x, not actually x, it is L, so this is not the extension, but if we look for the part here from 8 to 12, we can find the extension, which is 4, and this extension reached when force reached 6 Newton, and by multiplying by half we get 0.12, because 4 here is in centimeter, and multiplying by 10 to minus 2 gives us the as the final answer. If you want to find the area under the graph, you should notice that it is only this area, because before that, which is this area, the cord or the spring wasn't extended. Okay, so there is no elastic energy represented by area of rectangle below the triangle here. Young's modulus equal stress over strain. We have stress, and we also have the strain. It is 2.1 minus 2, which is 0.1 divided by the original length, which is 2. This comes up to numerator to give our answer as 3.2 times 10 to 6 Pascal. Stress is force over area. Force is in Newton, which is kilogram meter second minus 2 over meter squared. So when it comes up, it gives B. A rubber band doesn't return to its original length when the force is decreased to 0? No. When force is decreased to 0, it returns to its original length, because extension will be 0 when force returns to 0. Rubber band obeys Hooke's law for extensions shown. Actually, no, because we don't have straight lines, we have curves. Rubber band remains elastic for extensions shown. Elastic means that removing stress, it returns to its original length, and this really occurs. There is no plastic deformation where removing stress doesn't return the shape to its original situation. So C is correct. Okay, shaded area between the two curves doesn't give the work done in extending the rubber band, it gives the energy lost. Sound cannot travel in vacuum, cannot be polarized, can diffract through a gap. Okay, displacement to right are positive, and displacement from source is negative. Okay, so particle is moving away from source? No, because moving away from source means moving to right, and y is in the negative direction of displacement. Particle is moving towards the source. This is the correct answer. There is no upward and downward direction because it is a sound wave, longitudinal wave, just away to the right or toward to the left motion. A direct application for Malus law, we have I1 over I equals cosine square 50. Okay, so when light comes out of the first filter, we will have the ratio of the emerging light intensity to the original intensity. Perhaps we can name it as I naught. We have the ratio. If we calculate this by calculator, it will be 0.42. And for the second filter, we have I2 ratio to I1 as cosine squared cosine 30 cosine squared 30. We can write this as I2 to 0.42 I naught equals cosine squared 30. This value is 0.75, and we can multiply by 0.42 I naught. So we have that I2 is 0.315 I naught, and I naught is given by 8 watt per meter square. So multiplying by this number gives 2.5 watt per meter squared. Here we can apply Doppler formula and simply substitute as follows. So we get the answer